So very good morning, everybody. So this is the right choice for you to choose to go with the embedded and automotive systems with AI. So which is our latest upgradation in the diploma, PG diploma course from Varsity that we are offering in this academic year. Okay. So to tell you about the modules that we are going to take up. So in this course period with a duration of 6 months. So it will be there for 6 months. So the different modules, the different sections, and under that we have a different subsections have been divided. So the first one is the core engineering. So though you are good at your, basic electronics as well as the digital electronics part. So we would like to take it up. Okay, after you come here, so you should come to our page, so to brush up and to have the deeper understanding of basic electronics and also the digital electronics part, which is a base for our any embedded or the VLSI courses to go with. So we do have the first 10 days of training for electronics and hardware familiarization, which includes analog electronics also, digital electronics also, and also how so we go with the so interfacing the different peripherals apart with our microcontrollers or the processors. So that we are going to see in detail, and it will be more like a brush up. So that comes with our core engineering. So for 10 days, so that will be a quick brush up on these topics. So then we will move on to the core programming fundamentals. So this is completely a period of 35 days where you come across the different modules inside that. The first one is the mastering C programming. Hope my screen is visible to all of you. Kindly confirm. Screen is visible. The outline that I'm sharing to you is visible to you, Lavanya?
Yes, ma'am.
Yeah.
Yeah. Okay. Thank you. Okay. So the first part is mastering C programming. The second one is the competitive programming using C. The third one is data structures and algorithms for problem solving in C. The fourth one is the mastering group and data structures using C++. See, you want to become an embedded design engineer, okay, or embedded verification engineer, or any role in that case. So C and C++ programming is the must. So for when it comes to embedded, the data structures and its algorithms also a very important aspect or part of your course, the entire course of your embedded and automotive systems. So because the industry is looking for how competitive you are in solving the C as well as the C++ scenario based questions for them. So many clients come to us like National Instruments, other clients like Bosch, so or it may be Harman. Okay, so any different clients come to us, they first demand in the first round of the placement that goes with the C and C++ programming. Unless you are good in C and C++, so it will be very difficult to go to the next round. So that is why, so a strong foundation, a strong understanding, a strong preparation is very much required in C and C++. So that has been very clearly divided into different sub modules here. Okay, so that is mastering C programming, where you are coming across. So let me go through that. So I'll just come down so you can see that. So here, so core programming fundamentals, under that what are the different topics that we are going to take up. Mastering C programming is there for 10 days. So each day you will have a 4 hours a session, totally 40 hours it comes to. So according to the sessions, we divide it into 20 sessions because each session comes with 2 hours. Okay, so in that way, so each day you will have 4 hours of class. That means 2 sessions you will have. Okay, so in that, so you can see the topics that we are going to cover under this. It is an introduction to C with a simple C programming structure, starting from there. Literals, constants, variables, modular programming using functions. So operators, the precedence and its associativity, control flow statements with examples. So about the arrays, the string functions, searching algorithms, sorting algorithms, and also we take you to the HackerRank platform. So where you can solve the trending scenario-based problem-solving questions. So there you are going to get the solutions also, and you can understand what is the level of questions that industry is looking for, and you'll get the ability so to get into those questions and solve those questions and get more confidence for you to solve that. Okay, so second part is the competitive programming using C. There is a separate session for this. So here you have different topics like a time and space complexity, utopian tree, viral advertising, migratory birds, palindrome index, array rotation. So not only this, so many more along with this. So all these things in a competitive programming using C will be covered. So this is also there for 5 days. So it comes with 20 hours and 10 sessions. So each session is 2 hours. That's why it is 20 hours is 10 sessions over here. So then the third module, so that you have is the data structures and algorithm for problem solving in C. It comes with the 10 days of program. So with the 40 hours. So here you are going to get with your in-depth understanding of the pointers, declaration and initialization, types, pointers to pointers. We are going to discuss about the structures. You'll have the detailed understanding of the stacks, queues, linked list, which is very important topic, dynamic memory allocation, static and dynamic stacks. So static queue, dynamic queue. So linked list, in that you are going to get your singly linked list, doubly linked list, file handling using C, GitHub. So we are going to teach you the Git and GitHub also, and also will take you again here with the hacker ranking platform. So you're going to solve more problems over here. So to get competitive with the others in the real world. Okay, so the last one is the mastering OOP and data structures using C++. See, clients like Harman and all, so they'll be mostly looking into C++ also because they work on C++. So there are few companies, their complete focus will be on C++. So for them also, we have a full package of basic input or output operators. So then we get into the understanding of a namespace, introduction to OOPs concepts. We're going to discuss about the classes and objects in detail, encapsulation, data hiding, abstraction concepts with examples, with lot of examples, assignments, assessments. So every day after 4 hours of session, you will be having a lot of practice. You can sit in the laboratory. We have the laboratory facility for hardware programming, okay, and also for the software programming. We do have the lab facility. You can sit inside the lab. The remaining half a day session, either it may be morning session or the afternoon session. One session you will have the class. The other 4 hours you can sit inside the campus. You can take the help from the trainers over there. So what are the problems you want to solve? You can solve it over there and you can get back to home. So that facility completely we have from our end. So then we'll get into the other concepts like inheritance, polymorphism, exception handling, lambda expressions, smart pointers, templates, STL. STL is one more important topic, so that we are going to cover here. So which is very important for so interview point of view. So in that case, so we have just added the STL also. Again, here also we are getting into the more and more problem solving into your not only in the hacker rank, so we'll take the lead code also, and other platforms also we are taking. So just to mention, we have mentioned one platform. So all the different platforms, so we can get into and we can solve more problems. So this is the complete picture of C programming fundamentals, which comes with 35 days of training. So each one has been divided and it is more clear to you, right? Palak, Lavanya, getting? Sai?
Yes, ma'am.
Yeah, ma'am.
Okay. Yes. See, if you have any doubts in between, so let me complete, or you can ask, or you can stop me and ask. So I'm good to go with anyway. Okay. So next comes your, okay, the third one. So the third main topic is embedded systems programming and real-time control. So this is the core, okay, of your embedded and automotive systems with the AI PG diploma course. So where we come across embedded C programming following MISRA C guidelines. So using the MISRA C guidelines, we start programming with the embedded C and ARM Cortex M architecture. So we have different architectures. So M3 also we go with. So previously we used to go with the ARM 7 architecture, ARM 9 architecture. Now we are upgraded into ARM 3. ARM4 also. So ARM Cortex, ARM processor architectures we get into, and we learn how to program for a microcontroller here. So specifically we have mentioned it is LPC 1768. Okay, so it's LPC 1768 microcontroller. So in that you have a microprocessor, so which is ARM Cortex M3 processor that you are going to learn about here. So next is the embedded protocols and peripheral driver development. So most of your projects will go with the protocols, understanding and implementation of protocols for your projects. So understanding of the different serial communication protocols are very, very important, and also the CAN protocol so that we are going to take up. Okay, so here that's why so separate submodule has been kept for that. So where you are going to study about the different protocols and also the peripheral driver development here. So then comes with the RTOS. So of course the embedded systems. So we should have a understanding of the RTOS, real-time operating systems. So we do teach the free RTOS here. So it's a firmware programming part, so that you are going to learn under this. So I will get into the detail of that one. So this is what is the embedded systems programming and real-time control. Just a minute. Yeah. Okay. So this is the embedded C programming following MISRA C guidelines. So which is there for 5 days. So it comes with the 20 hours of training. So here you are going to learn about the cross compilers. So where you have the compiler, assemblers, linker, debuggers, GDB, and all these things, conditional compiler directives and their significance in embedded software. So then we also learn about the constant, the volatile qualifier and their use in embedded systems, then bitwise operators and their use in low-level programming, the structure padding, bit fields, functional pointers, make files, building an executable file, startup code, linker script and their use, object file and file map file, debugging and tracing, which are the important topics. So let me tell you one of the company, like one of the claims that comes to us, the Ray Semiconductors. Okay, so they especially asked, and a few more companies. Okay, so they wanted the so students to get trained with the debugging as well as the tracing concepts. So we introduced that also, so which will be an additional value for you. So to attend your interview properly and get through those interviews. Then coding standards or guidelines for secure and safe coding. So that is one more. Then the third module comes with, the second submodule comes with ARM Cortex M architecture and programming with LPC 1768, which is there for 10 days with 4 hours a day, comes with 40 hours of total training for this particular module. So you are going to learn about the architecture. First we should know how does the Cortex AM3 architecture exists, so how it is, so what are the internal features of that one, how does it work. So after knowing all these things, then we will see how it has been used by the NXP Semiconductors to develop the microcontroller LPC 1768. So after understanding, after having the complete overview of that microprocessor and the microcontroller, then we will get into the GPIO registers, GPIO programming, general purpose input output registers. First we'll understand the registers, then we'll get into the programming part. So with LEDs only a lot of different patterns are there. So how the programming can be done with the help of embedded C, so that we are going to see over here. So next we get into the other peripherals, like how LED, buzzer and also switch can be used along with your so LED programming patterns. So to go with this, so you can so use a lot of logics over there. You can glow your or toggle your LEDs with the different patterns. So many things you can use. So after having the complete understanding of the programming part from C, over there. So here it is an implementation. So those logics should be implemented here. So it should have a strong understanding of the programming part in C over there. So that we are going to implement over here. So then after the LED, the buzzer interfacing, and also the switch interfacing, will get into the LCD part. So we are going to interface the LCD and its programming, and also the hex keypad. So that we are going to do. See, actually, so for this particular one, we come up with the evaluation board. Okay, so let me show you that picture if I have. Yes, so I do have. So can you see this? Can you see this board? Yes.
Yes,
Are
ma'am.
you able to? Yes. So this
Yes,
is the
ma'am.
evaluation board. Okay. So this is the evaluation board that we have. So when we get into the hardware, see, there's a third module, whatever are the topics I'm talking about, right? So after your embedded C programming, so we just start with this evaluation board. Every day you will take this evaluation board or the development board. So this is the LPC 1768 evaluation board, which includes your ARM Cortex M3 processor. Okay. So this is our microcontroller, and here you have. So what are the program peripherals I'm mentioning right now? Okay, so all those things are made here. Okay, so you have your, can you observe this LCD display? Right, so you have the LED 7-segment displays here. You have the LEDs over here, and you have a CAN protocol connection over here. Okay, so it comes with UART, it comes with I2C, it comes with the hex keypad. Okay, it comes with the ADC, PWM, the buzzer. Okay, all the required, the memory, EEPROM, so to interface with your I2C protocol. See, everything. So we have a evaluation board. So whatever the topics that I'm mentioning over here, under here, okay. So all these things, see, PWM, for that we have one particular block. RTC, we have one particular block for that. Watchdog timer, we have one. PLL, NVIC, nested vector interrupt controller. Okay, UART, serial peripheral interface. UART, from UART it is the protocols. Universal asynchronous receiver transmitter, serial peripheral interface, synchronous serial peripheral SSP communication, and also I2C inter-integrated circuit. So these are the different protocols, so which has been already developed on your that evaluation board. So you develop an embedded C code, so to evaluate, so how exactly that peripheral is going to interface with your microcontroller and communicate with your microcontroller. So this is what is this entire module is about. So this module and also the previous module. So for both of them, so you are going to use this particular evaluation board. So you develop the code. So the trainer will explain in detail what are the different steps that has to be taken. So 1 or 2 programs will be taught to you the same way you are going to take up. You are going to develop. You will develop that, cultivate that habit of developing the embedded C codes for these peripherals, and you write the code, you get that confidence to work out on, and you interface the different peripherals, and you see the output. Okay, so that's how you are going to learn all the different peripherals and also the protocols with your embedded. So is that clear, everybody? Sai, Lavanya? Okay. Thanks for the confirmation, Lavanya. Lavanya says Shashi Kumar is here, Meenakshi is here, Moksha is here. So I think I have not taken your introduction, so that's okay. Okay, so any doubts still here, Shashi Kumar, Meenakshi, or Moksha? Good to go with? Pujita? Lavanya? Sairam? Okay, so maybe you may be outside soon. Meenakshi, can we talk? See, if anything is there, please let me know. So feel free to talk to me. So we can have, so whatever the discussion, whatever the doubts you have, I can clarify that. Okay. So let me know. So we should have, you should understand. So how exactly it is going to work. So you will have the more clarity and you can also take up the decision further. Yes. Okay. Fine. So let me continue. Yes. See, after this, we start with the embedded autos. So free autos we are going to take up here for 5 days. It is the entire autos program will be there for 5 days with a 4-hour session per day. So totally it comes with the 20 hours again. So here we are going to talk about the features of free autos and its source code organization and all those things. And we also have the hard real-time versus the soft real-time, multi-threading, multitasking, concurrent execution concepts. Then we get into the scheduling and context switching, so which are the important concepts in autos, and we get into memory management, followed by different schemes in allocation, in memory allocation. So free autos, heap utility functions, optimizing the memory and all those concepts. So then we'll get into the concepts of free autos tasks, APIs, creating the task priorities, task state transitions and all those things. Then we also take up the training on tick, interrupt, idle task and all those things, and a free autos queue, block reading, right receiving data on multiple queues, then interrupt management, semaphores, resource management and all these things. Okay, so with this, the core part of your embedded is here. So here, see, this is what is the main thing: embedded systems programming and real-time control. So this is for 30 days. Okay, so this one. So then comes, that should be followed by a 5 days of, okay, prototype development, or we call it as an experiential project based learning, where you are going to develop a prototype using your LPC 1768 using the 𝐂𝐫𝐚𝐬 IDE. Right. So till here you understood the concepts of basic electronics and digital electronics. So then you understand the complete programming aspects in the second module. So then in the third one, so you understand the complete understanding of embedded systems and programming and real-time control. After all these things, you should be able to develop a prototype, so using LPC 1768. So that is there for 5 days. You have to sit in the laboratory and work out for complete 5 days. So it is not 4 hours, complete 5 days. You have to sit and you have to develop a prototype and with your interest. So you can take it up so with any of the protocols, or you can take it up with any of the peripherals. So it doesn't matter. So which is your interest? Because, so this is a mandatory thing, because the see how the interviewer will assess you when you're sitting in front of them. So it is not that marks that we are going to give. It is not the based on the, so certificate. Okay, so it is based on what is the project that you have done and how depth of understanding that you have on that. Okay, so whether you have done it or not. Correct. So you should have a complete understanding, that practical understanding, and whether you will be able to solve that particular problem or not. So that they are going to see from you by assessing through your project. So you should be able to explain to them, so how exactly you have done your project. So that is why this project development of the prototype is compulsory, and you have to give the presentation at the end of the day after 5 days completion. So that will be a additional thing. So you have to, so good to go with the project development or the prototype development using LPC 1768 microcontroller. So then comes your specialization. We have certain specializations along with the embedded. So that comes with embedded Linux. So you know how important the Linux is. Okay, the embedded Linux fundamentals and user space programming. So user build systems and kernel level programming. These are the sub modules that we take up under the embedded Linux, which is there for 10 days. And then comes with the IoT systems. So in the IoT systems, we are going to take up the IoT protocols, cloud integration, and also the dashboard development. So then finally, the next one module comes with embedded AI and automotive foundation. So let me go through this first, then I'll get into this. So just I'll scroll down. Embedded Linux and IoT systems. So here we are going to take up the Linux concepts. So the Linux fundamentals and also the user space programming. So which is there for 40 hours of training. So here we are going to cover the Linux operating systems, the structure, kernel versus user space, boot process, the process management and package handling, shell scripting basics, variables, conditionals, loops, writing scripts, and all those things. Python essentials for IoT, the data types, control flow. Also, we are going to teach your file input output, the exceptions, GPIO and peripheral access using Python, accessing GPU, and booting custom Linux on Raspberry Pi bootloaders. So, which are very, very important concepts. So, in your Linux. So then comes your with your IoT protocols, cloud integration and dashboard development, which is there for 40 hours again. So you are going to understand the very important protocol. So MQTT is a lightweight protocol. So we understand what is this particular protocol, the architecture of that one. So how you will interface that with the real sensor. Okay, so how you are going to interface that and how that particular module will work with the subscribe as well as the publish. So that we are going to see there. So other protocols like a HTTP protocol for IoT we are going to see, and also the cloud platforms like the ThingsPod or the ThingsSpeak. Okay, so then comes with a Blink. So AWS IoT overview. So Adafruit also we can use. So they'll just see the trainer will see. So which is the most feasible one, and you'll get into that. And a cloud integration, the things for publishing via MQTT to the cloud, the JSON formatting. So these are the different cloud concepts that you are going to learn over there. And also the dashboard development, creating the live dashboards using gauges, charts, and alerts. So where you can have the real-time data collection, data visualization, and also the data analysis on the cloud. Okay, using these platforms. So very, very interesting it is. So it's going to be, so more useful for your embedded, along with that, the IoT concepts. So then comes your embedded AI and automotive specialization, where you have, see, the trend is towards the AI. So we have also introduced one more, module under that. Embedded AI and edge intelligence is there for 5 days, comes with the 20 hours of programming. Okay, so here you have introduction to TinyML and Edge AI. So there, cloud AI, embedded AI use cases are used. So sensor data acquisition, how the real-time data collection and visualization is done. So example, by using the serial plotter. See, that's what. So from the sensor, how the data is collected and how you are going to visualize it. So that is the important thing. So first thing that we are going to do. Then comes with the feature extractions. So the techniques that you are going to study here by using the Python or the MATLAB based feature extraction can be done here from the sample sensor data. Then introduction to ML for microcontrollers, basic ML concepts, classification, regression. So these are the different concepts that you come across in the machine learning. That machine learning concepts you are going to learn here, the training and testing. So first is the classification, regression, training, and also we get into the testing. TinyML model optimization, quantize and test model using TensorFlow Lite, the lighter version of the TensorFlow, and the AI model deployment. So these things you are going to learn under the first sub-module. Then comes with your automotive foundations. So here you have your ECUs, types of ECU, sensors and actuators, automotive systems overview. Here the entire thing. So automotive means, so which protocol comes to your mind? So which is the protocol that comes to your mind when you take up the concept of automotive? So it's a CAN, right? So what is CAN? Can anybody say? Anybody has an idea about what is CAN? Who developed it? Any idea? Sai? Mr. Sai? Lavanya? What is CAN?
Controller area network.
Yes, it's a controller area network, right? So mainly it's used in the automotive industry for automobiles to communicate with right? Okay, so because it can be used for a longer distances. So where your UART, SPI and I2C comes with a shorter distance and your CAN will go with a meters distance. So your serial communication protocols comes with a centimeter distance and this CAN comes with a meters distance, half a kilometer, 1 kilometer. So you can connect with, right? So the entire, see again, here in the CAN, whatever the evaluation board I have showed you, so there were two wires that had been connected, right? So let me just go back to that. So can you just see here? So this brown color and this red color. So this is a CAN. Can you just see here? See here, this part, correct? Okay. So here you have the CAN interface also. So there you will just take up the connections for the CAN and you are going to whatever the program or embedded C program that you are going to develop for both, so the transmission as well as the reception, so that you are going to evaluate on the evaluation board of LPC 1768. So those are the concept that has been introduced here. And also it includes your LIN bus also one more. Along with the CAN, we will also go with the understanding the working principle of the LIN and its applications also. So that is one more thing that we are going to cover over here along with the CAN architecture and the CAN features, CAN arbitration, how exactly the CAN is going to work. So we do write the programming and we do evaluate that. After that, we get into the LIN bus. Okay, its working principle. So these are the two protocols that you are going to study under automotive. Okay, so next is the Qt application development for automotive system. So here you have the introduction. So this is the newer concept so that you are going to have. So here you will have the introduction to Qt framework. So the setting up of the Qt, so there is the specialized persons for this. So they are going to talk to you about this Qt. So we'll have a special sessions about Qt for you. The creating your first Qt widgets and applications, Qt widgets and layouts, GUI design using Qt Designer, integrating the C++ classes with your Qt. Okay, so all these things, so it's mainly for the, so automotive is related to this Qt application, so that you are going to get. So it's completely for the infotainment. So you can have, you can develop a simple infotainment UI also here. Okay, so that is what, so this is the one new introduction. I don't think anybody else are going to offer this particular, so particular module. So it's completely from cranes, so that we are offering. So at U level, okay, so after completion of your, so immediately after graduating, so it's a very good value addition for you to understand this Qt application development. So you'll have a lot of opportunities in the automobile as well as the automotive industry. So to take up this particular module and have the understanding, and also to develop a simple infotainment UI. See, after understanding that, you can develop on your own. So once you get the basic knowledge, the fundamentals on that, so then you can start working on that. So next, the last one is the model-based design for AutoSAR model deployment using MATLAB and Simulink. So MATLAB. So it's again, so MATLAB and Simulink. So it's a wonderful tool, so that we take up for model-based designs for ECUs. So here we are going to understand the data types, addressing techniques, linear equation, so different graphical user interface, logic design modeling, finite state machines, the SimScape, controlling the different motors, so model a basic software. So all these things so comes up in the last module. So MATLAB also you have along with all the other modules so that we have. So this is the last module that we have. So this one is especially embedded AI and automotive specialization. So it's really a specialization topic. Okay, so nobody else will offer this kind into your so embedded embedded modules along with the embedded modules, I mean to say. Okay, so this is a power package, I can say. So you will have the entire starting from the basic electronics So which is very basic. See how it is organized and structured, starting from the very basic understanding of digital electronics, and starting from your NOT gate. Let me say from the NOT gate, from the diode. Okay, so till you are getting into the complete understanding of the different languages that you are going to take it over here, and then getting into the embedded concepts, then getting into the IoT concepts, then getting into the Linux, and also you are going to end with the latest technology of Qt application development, and also your AutoSAR model deployment using MATLAB and Simulink. So then what else you want? Right? So this is the project stream that we have here, this side. So you can just see. So you can develop your multi-peripheral integration projects you can do using GPIO, UART, SPI, SVC. That's what I meant. So I already told about the, so experiential learning or the prototype development. So using all these things, you can search. So you can take your time and you can develop a very good prototype. So then you'll have more confidence in, so delivering your interview, so to the interviewer. Okay, so then you can develop a custom CAN-based protocol for vehicle networks. So these are the different platforms that we are going to use. So if you have so any doubt about which are the different platforms that we are going to use for this, Ubuntu, so Linux OS with the GCC compiler we are going to use, WSL Windows subsystem for Linux, and code blocks, VSC and Div C++ we are going to use, and LPC 1768 development board we are going to use, which is a hardware. So already I had shown you that picture also. So which is evaluation board or the development board we call it as. So completely hands-on, you are going to get every class you have to take it. So you have to work out. So all the hardware modules will be taken with the help of LPC 1768 evaluation boards, and free autos we are going to use 𝐂𝐫𝐚𝐺 IDE and also the Flash Magic. So for this, so Flash Magic, so whatever the programming that you have done on the embedded C programming that you are going to develop on the 𝐂𝐫𝐚𝐺, so that will be converted to the hex key file, and that should be flashed onto your microcontroller. How does that happen? So that will happen after you use your Flash Magic. There you take up your hex key hex file, and that hex file, so you will dump it onto the microcontroller. Okay, because your microcontroller will understand only zeros and ones. Okay, so next comes with your Raspberry Pi 4 boards and Raspberry OS, ESP32 board for your IoT. So all your IoT that different protocols I mentioned, MQTT, HTTPS, and different platforms that we are going to use. So ESP32 boards we are going to use, room version we are using that, and MicroPython. MicroPython is the language that we have to use. So Python basic understanding should be there. So after that, so we can get into MicroPython. So MicroPython for microcontrollers is your MicroPython. So you'll have the deeper understanding over there. So Thani IDE will use, so that will be more feasible for us to write your MicroPython code and interface with your ESP32. So Thani IDE we are using. So ThinkSpeak is one such platform. Blink platform we'll use. AWS IoT also we use. So MATLAB, that's Simulink, so that version, different latest versions we are going to use for the MATLAB as well. Okay, so this is the complete outline with for a 6 months duration. So in between you will have your mocks. Okay, after completion of each module you'll have your mocks. So you have to clear the mock. You will have your module test. Weekly assessments will be there. Okay, so every week there will be assessment on Friday. So weekly assessment should be regularly taken up. So after every module completion, there will be a module test. So that you should compulsorily clear. So then after certain modules, you'll be moved into the placement after conducting a mock. So after that, so you need not to wait for all the entire 6 months. So in between, so once your programming part and embedded part is over, so you can get into the placement if you clear your mock. So then your placement process will be parallelly going on. So then after the completion of the entire thing, so you'll be certified with a PG diploma in embedded and automotive systems with AI. Okay, so till now, is there any doubt? Lavanya?
No, ma'am.
Is that clear, Lavanya?
Yes, ma'am.
Okay. Sairam?
Yeah, ma'am. Clear.
Okay. So
I have a doubt,
anything?
ma'am.
Yeah,
Ma'am,
please,
what
Sairam.
difference between MicroPython and C, ma'am? Major in
Yeah,
embedded.
see, yeah. See,
Why?
tell me.
Okay, continue.
Please continue. You continue. Complete your question, then I will answer.
There is a very lag between MicroPython and C. Why?
No, see, C is entirely a different language, and Python is a different language. You know that, right?
Yeah, ma'am.
See, why we teach C is because it will be easy for us to develop the embedded C codes. Embedded C codes will be
Okay.
developed by using the C. The LPC 1768 I had shown you, right? So that will be evaluated by developing the embedded C programs. So for that, what is the basic? You should have the complete
C.
understanding of your C language. Okay, so
Yeah, ma'am.
that is different. Then Python
Okay.
is another language, high level language, correct? So
Yeah.
it
Yeah,
comes with
ma'am.
the more number of libraries and packages, correct? So it comes with the
Packages.
number of libraries. So inbuilt libraries are there. You'll just pick up that one and you will do that, correct? So when it comes to IoT, there we are using the MicroPython. Okay, only for embedded part now. That embedded part I
Ma'am.
had shown you here, right? Only for
Yeah, ma'am.
that,
Yeah, ma'am.
yeah, only for that we are going to use this module. Okay, I'll just show you. I think I had shown you. So until there, see
Yeah,
completely
ma'am.
this part. Okay, so here we develop some programming for your MQTT protocol. So in this part, we require that MicroPython. It's very easy, not so difficult. Okay, so if you have basic understanding of Python, so easily we can get into the MicroPython. Okay, only
Okay,
for
ma'am.
this module, only for this I'm talking. Otherwise, your automotive module, your CAN, okay, and the entire embedded part, everything comes with the basic understanding of C only, because here you are going to develop the embedded C programs. Okay.
Okay, ma'am.
Okay. So anybody else? Palak Srivatsau, any doubt, Palak? Let me know.
No, ma'am.
Oh, is that clear? Okay. Okay, Palak. Thank you. Pujita? Pujita? I think she got disconnected. Shashikumar, Mr. Shashikumar T. Mr. Shashikumar T, any doubt? Would you like to take out some 5 to 10 minutes of demo? Palak Srivatsau, Sairam, Shashi, Mr. Shashikumar.
Sure, ma'am.
Okay, so just one simple topic I'll just explain. See here, everything we are going to have in terms of, session wise. Okay, so I'm not going to share you the latest session wise PPT, but whatever previously I have. So let me go with that. So I'm going to give, so one small demo to you. Okay, so let me talk to you about the ARM processors. Okay, so ARM is an advanced risk mission. Okay, so ARM has acquired so most of the companies today in providing its architectures. So I heard recently that now they are into manufacturing also. So most of the time, so what the ARM company does is, so they just give their architectures. So the individual microcontroller companies like your NXP, Atmega, okay, and other companies also, so they just take the architecture from this, even Intel, okay, so they take the architecture from the ARM and they develop their own microcontrollers. Like NXP develops its own microcontroller like LPC1768, LPC2129. So like that, many versions of the microcontrollers they develop. So basically ARM is a advanced risk mission. So previously it was a joint venture between Acorn, Apple and VLSI. So later, so it has become so advanced risk mission. Okay, so ARM alone it is. So the licenses, it licenses its high performance, low cost, power efficient risk processors, peripherals and system chip designs to leading international electronics companies. So that's what I meant. So it will just give us what architectures. So why it is developed so much, so it is standing in the top because of these reasons. So the architectures comes with a high performance, lower cost, and they are power efficient RISC processors. The name itself is saying they're not developing the CISC processors, they are only into the RISC processors which are power efficient, and they come with the low cost, and they come with the high performance, and they come with a lot of peripherals to interface with, and also the system chip designs like SoCs and all. So that is how ARM has got into the leading international electronic companies. So these are the important features of ARM. So which is ARM 7 actually here. So different versions of ARM processors comes with the different features. One such is ARM 7. So these are the different features. I'm going to mention it over here. So it comes with either 32 or 64-bit RISC, which is an advanced mission or architecture, you can call it as. It operates up to 60 megahertz. So 32-bit ARM instruction set for maximum performance and flexibility. So 16-bit thumb instruction set for increased code density. Unified bus interface, 32-bit data bus carries both instructions and data. So 3-stage pipelining. So that is fetch, decode, and execute are the 3 stages that comes in the pipelining. And a 32-bit arithmetic and logic unit. So it comes with the joint test action group, that interface debugging unit, and also the 32-bit so memory addressing range. And also it comes with a different modes like user mode, FIQ mode, forced interrupt request mode, interrupt request mode, and also the SVC mode, undefined mode, and abort mode, and also system mode. So these are the 7 different modes it works with. So in detail, so there is a lot of explanation regarding that. So this is the architecture actually. So here you have the, so you can identify that address register, the address. See, basically, so any processor, so it is meant for its computations. So how quickly it performs the computations. So here, along with the ALU, you can observe at the lower end, you have a 32-bit ALU. So that is nothing but a 32-bit arithmetic and logic unit. So it comes with a barrel shifter and also a multiplier. And this is the register bank about that. So around 31 registers. Okay, so 30 into 32-bit registers. So in that 6 status registers are available, and also the address register and the address incrementer. So here you have the ALU bus, you have the address bus, you have the data bus. Okay, so when you have a, what is an ALU actually? What is an ALU? What's an ALU? Anybody? In a processor or a controller, what's an ALU?
Logic unit.
Arithmetic and logic unit. What does it do?
It is a CPU which control the device
Okay, so let me tell you very simply, all the arithmetic as well as the logical instructions, whatever you give, right? All the arithmetic as well as the logical operations will be performed in this particular unit. And you just tell me one thing, just one thing. So what do you call, okay, it as a 8-bit processor or a 8-bit controller or a 16-bit processor or a controller or a 16-bit microcontrollers, 32-bit processor, 32-bit controller. On what basis you call it as so and so bit microcontroller or a processor? Yes, anybody? See, ARM usually it gives 32-bit processor. It's a 32-bit processor, 64-bit processor. Okay. So can you just mention any one 8-bit microcontroller and 8-bit microprocessor, 16-bit microcontroller and 16-bit microprocessor, one 32-bit microcontroller and one 32-bit microprocessor to me, please? Yes. One 8-bit microcontroller. Can you name? 𝐂𝐫𝐬𝐢𝐭𝐲. Have you heard of 8051? Correct. 8051
Yes.
is a 8-bit microcontroller. Correct. How about your 8085, 8085? 8-bit microprocessor. Correct. Oh, how about your 8086? 16-bit microprocessor. Can you just name one 16-bit microcontroller? MSP 430. Okay. So MSP 430 mixed signal processor microcontroller, which is a 16-bit microcontroller. Okay. So then comes what your 32-bit microcontroller, 32-bit microprocessor. Can you just name one 32-bit microcontroller or processor? Just now I'm telling now. So ARM7, okay, ARM Cortex M0, M1, M2, M3, all these are 32-bit microprocessors. So that microprocessor will be used inside your microcontroller. LPC2129 is having ARM7 as a microprocessor inside that. LPC1768, which one I told you? ARM Cortex M3 processor. So both are 32-bit. Okay. So these are the different. Okay. So 8051, 8-bit. MSP 430, 16-bit. LPC 2129, LPC 1768, 32 bits. On the other side, these are the microcontrollers. Microprocessors 8085, 8-bit, 8086, 16 bits. Your ARM7, 32 bits. Your Cortex M3, 32 bits. So these are the different microprocessors. Is that clear? Okay. So based on how many number of bits it can take at a time into your ALU, that means the data bus, how many bits of data it can access at a time into your ALU. Based on that, your microcontroller will be named as 8 bits. So your data bus is 8 bits of data. So that is taking into the ALU. Then it is 8-bit microcontroller or a processor. If it is able to take 16 bits of data and 16 bit of into your ALU, so that is your 16-bit microcontroller or processor. If it is able to take 32 bits of data or access, so it is called as a 32-bit microcontroller or processor. So here, can you just see that bus? Okay, how many bits it is? 32 bits. Okay, so it is a 32-bit microprocessor, which is a ARM7 here. This particular architecture is ARM7s. So though it has ALU, 32-bit ALU, where all the arithmetic as well as the logical operations will be taken care, but still there are separate multiplier block here, 32x8 multiplier block is there, and also a separate barrel shifter is there for the parallel computations. That is how it will increase the performance inside your microprocessor. Okay, so this multiplier is for a 32-bit x 8 multiplication, and here barrel shifter for performing the shifting operations, right shift, left shift, correct? Okay, shifting operations. rotations, rotate right, rotate left, all those rotate operations as well as the shifting operations will be performed in this barrel shifter. And you have the register bank. And you have the address incrementer for this address. So with the help of this address register, you give that, and there is address incrementer. Every time it will increment the address by 4, because so it is a 32-bit. So 8 bits will be saved in each register. So it will be incremented by 4. Okay, so there are some enable registers, enable pins here and control pins. So can you just see here at the end down, you have this D31:0. So this is what is your, so what is that? So data, so that you are taking 32 bits of data here. So here, this is the scan control, instruction decoder, and a control logic. The entire thing is a control block here this side, and these are the different control registers. So this is the basic simple architecture of ARM7. So similarly, I have the architecture for which one? Architecture for ARM Cortex-M3 processor. First, we'll get into the Cortex-M3 processor architecture understanding, where it has NVIC, it has its ALU, it has its debug unit, along with that, so memory block. Okay, optional memory protection unit is there. So along with all these entire things, we are going to explain the architecture, its important features, and in detail understanding of those features. So then we will get into the understanding of your microcontroller LPC1768, its features and its applications or evaluations with the different peripherals interfacing with that LPC1768 microcontroller. Is that clear? Yes, Sai? Pujita?
Yeah.
Yeah, ma'am.
Yeah. Okay. Palak Srivatsov?
Yes, ma'am.
Okay. Okay, so this is what is the simple demo. I just wanted to give it to you. Okay, so about the architecture. So this is what we follow. So if any doubts, okay, so let me know. Fine. Akash?
Yeah, ma'am, I can hear you, ma'am.
Yeah, so I'm yes, I'm almost done. So would you like to hear for VLSI also?
Ma'am, yeah.
Yes, ma'am.
On.
Yes, Akash, please let me know anything.
No, it's fine. It's fine. Go on, ma'am. Yeah.
So just to quickly, I'll just show you the outline. So not in so detail, but I'll just show you that you can have a quick look at it. So see, VLSI is also, so trending today. So PG diploma in VLSI design and ASIC verification also we do offer for the same duration of 6 months with the modules covering core engineering, which comes for 10 days. So here my more focus will be on basics of analog or digital electronics and logic design. So then we'll get into the hands-on circuit simulation and debugging concepts, a few concepts. So but more focus will be there on digital electronics here. So then we'll get into the concepts of analog also. So then we'll get into the core programming fundamentals. So for 20 days, 80 hours we are going to cover here. So C and C++ here also it is very important. Why? Because I will tell you Verilog is the language which is based on C programming. So for that, C fundamentals is important. And so National Instruments is one such client that we have got last time I just mentioned, with the highest package they come with. And but so since though it is a VLSI company, so they look for C and C++ understanding. Okay, so that will be the first round. So we also include C and C++ here. So because Verilog programming is based on C, and the system Verilog, the verification language, is based on C++ with 𝐕𝐚𝐫𝐬𝐢𝐭𝐲 concepts. Okay, so that's why we do introduce. We have 20 days of elaborated training based on these two. So we'll get into the detailed understanding of mastering in C programming, and also with the C++ with 𝐕𝐚𝐫𝐬𝐢𝐭𝐲 concepts, which are mandatory for system Verilog to learn with. Okay. Next comes with the core concept, that is core module, that is VLSI design. So here we are going to program your RTL designs with the Verilog HTL language. So here we do cover VLSI fundamentals and design methodology. It comes with the different styles of modeling, conditional and procedural statements. So RTL, advanced RTL designs like your 𝐕𝐚𝐫𝐬𝐢𝐭𝐲 emissions, PWM, okay, clock generation, clock divider, circuits, and all those things we are going to take up here. Then we also go with the same protocols, 𝐕𝐚𝐫𝐬𝐢𝐭𝐲 and I2C on chip peripherals we are going to design, and also we do implement that on the hardware, that is FPGA. That is also there. And 5 days we take that experiential project based learning. So how you have there 5 days of experiential learning, here also we do have that. So that's a compulsory mandatory thing that you have to design and also implement that on the FPGA. Then comes with the specialization. So I come with that specialization of system Verilog for the verification design here. So which is there for 25 days and 100 hours of vast, so training that going to take up for the verification, so which is in demand. Okay, so design and verification using system Verilog, and here we come up with the concepts of whoops, assertions, and coverage, and also the complete verification environment design. So next comes with the ASIC verification using UVM. Okay, and timing verification also we have, including here for the topics or static timing analysis. So starting from the linting, okay, clocking, the clocking concepts, okay, all those things we introduce here. Then metastability, so many concepts are there in static timing analysis. All those we cover. So until we do the complete analysis of the timing for a digital circuit. So here project stream goes with the core programming concepts, application development based on data structures. So these are the different projects you can take up: design and simulation of digital controller or CPU core protocols such as UART, SPI, 𝐕𝐚𝐫𝐬𝐢𝐭𝐲, and AXI. And also you can come with the design, simulation, implementation, and verification of digital controllers, ALU cores, protocols such as UART, SPI, 𝐕𝐚𝐫𝐬𝐢𝐭𝐲, and SV. So that is system Verilog verification and digital controller for CPU and all those things, and UVM also you can utilize. So next, the different platforms are Xilinx Vivado, so that we use it for RTL designing and also for the implementation onto the FPGA. We do have RT7 boards and also the Zinc SoC physical boards are available with us. On that we are going to implement the designs, and also the Questa SIMR EDA background we use it for the system Verilog programming. And EOSIS and OPER timer, so we do use it for the static timing analysis. Okay, so this is the elaborated topics that we have, so in each module. Okay, so this is also our one more so stream in VLSI design. So along with the embedded and automotive AI, so this is one more PG diploma course that we have. I just wanted to add to you. So if somebody is interested in VLSI, you can also go with the VLSI design and ASIC verification PG diploma course for you. So decision is up to you. So both are good fields, and you can choose one of them. So you can go with one of them. Okay. So now you tell me. So any more doubts or anything to ask for? So let me know, so I can just get into that and I can tell you even more clearly. Sairam, anything from your end?
Okay. No, ma'am.
Okay. Miss Palak Srivatsav, anything from your end? Pujita?
No, ma'am.
Clear, Pujita?
Yes, ma'am.
Okay. Meenakshi? Yes, Meenakshi? Okay. Akash?
Yes, ma'am.
Yeah. Anything else from my end, Akash? Can we wind up?
Yeah, ma'am. I think we can wind up, ma'am. For the students, ma'am, I have in the chat box If you have
Okay.
any queries regarding the admissions, if you have any queries regarding the curriculum, I have dropped the email ID. You can definitely reach out to us.
Please note down the email ID that has been shared to you from Akash in the chat box. Any queries anytime. So later also, if you get something, so you kindly mail on that number, mail on that mail ID, so they'll revert back to you.
I am actually dropping my WhatsApp number also. So
Okay.
if you have any queries, if you have any issues regarding the curriculum, the placements, and the course structure, you can definitely reach out to the WhatsApp number or to the email ID.
Yes, yes. Number is also given, so you can share it on the number. So quickly, right? So training@𝐂𝐻𝐵𝐺.com is the mail ID, and you can note down the number shared, mobile number shared to you. So anytime, so you can get back. So get your doubts cleared, and you can take up the course. So hope this is clear. So please note down this, or you can take a screenshot or keep it for later use. Thank you, everybody.